Um, I would suggest you call these notes. You've got in front of you there, you've got 3 handouts. The only one that's really important is that weird one with all the drawings on the front. That I will tell you where I got that from. When I was sitting in a physics class in 1983, I got that. And it's lasted that long, yes. And every year I say, I gotta clean it up and make it look modern, but it kind of reminds me of my youth, so that's why I keep doing it again. So you get to do a sheet that I did when I was 16 years old. Long time ago. Yes. Thanks to Mr. Hart for that. Little shout out to Mr. Hart. So what you're going to do today is you're going to draw electric field lines. We're going to do the notes right here. So this is sort of me, the teaching part, and then this is where you'll do the practice, okay? So you should probably write down this stuff up here on loose leaf. And then I got some notes and stuff here, okay? So I need those phones down. I need your attention. I'm just giving it to you to sort of have for the weekend, just in case people want. I'm not a fool, Shelby. I know. What am I thinking? Okay. Have you drawn that yet? Yeah, don't draw that. That's just there to freak you. Yes. Yeah. I thought it was kind of cool. Okay, so let's begin. So we've already seen, this is just preamble stuff. You just need to be able to draw the field line. Andrew, I need you to listen now. Okay? Listen, guys. Here's the teaching part, the learning part. For every action, there is an equal and opposite reaction. I do the teaching, you do the learning. Because you're not listening to me. That's why I'm saying it to you. We've already seen electrically charged objects that are able to exert force, attraction, or repulsion on one another without these objects actually being in contact. What's that called? Action at a distance, or a force at a distance. Is any of that important? No, that's all preamble. Don't write that down. It's a big waste of time. An electric field is thus defined as, and you probably have this in a handout somewhere. If you want to write it down, you can write it down. Thus defined as a region of influence around the charged object can be made visible when small objects like grass seeds or pepper grains are placed near an electrically charged object. So it's a region of influence around a charged object where other things, other charges, will experience a force. Just like the magnetic field lines that you see when you put iron filings around a magnet. That's what an electric field is. One of the questions that I suggested that I might ask you is, what's the difference between electric fields and gravitational fields? What's the one major difference? Yes, electric fields can push and attract. Gravity can only attract. Unless, of course, you're antimatter. There, I taught a little bit of that modern stuff. It'll remind me to give you your test back. Or at least just see sure the mark. I got the test one. Okay, so that's an electric field. So, you're going to draw the appearance of electric field in one case. Now, you've seen the first one already, right? I got a positive charge here. What does the electric field look like around a positive charge? Away or towards? Away. Oh, hang on. I went to the next page there, didn't I? How do I go back? There we go. Now, does it matter how many arrows you draw? Not really. I tend to draw 8 just because it's sort of a nice, sort of even number kind of thing. Does it matter how close they are? They should be reasonably spread equidistant, like the same distance apart, kind of thing, but I'm not going to get out a ruler. All I really care about, Brendan, is the direction. And if I said, well, here's a field, draw one that's stronger, what would you do? You would draw more of them. And if I asked you where they are weak, you would say out here at the edge, and where they are strong would be in there close. It's the density of lines, how closely they are packed. You see how I keep repeating things over and over again? Why do you think teachers do that? So you know them. People that aren't listening hear them at least once. People that are away hear them at least once. That kind of stuff. Okay, so over on the right-hand side here, I've got a positive and a negative. Where do the lines go? Away from positive and towards negative. Like straight towards? Well, that one goes straight towards, but this one kind of goes like this. And kind of curved. And are there some over here? Absolutely. And are there some over here? Absolutely. And what happens if you get your arrows on the wrong end and you go from negative to positive? Well, it's wrong. So don't mess that up. Huge. Could be like 8 marks. Either you got 8 out of 8, or you're going to get 0 out of 8. It's a lot of pressure. But all you got to remember is away from positive. Think anyone in the history of grade 11 physics with Mr. Bennett has gotten 0 out of 8? No. I'm afraid so. I could not believe it. I literally screamed out loud at home and went, "Are you kidding me?" I may have, Shelby. I may have said a word that you probably have never heard. I think it was in Spanish.
True.
Okay, away from positive towards negative. Every once in a while you hear those words in movies. Okay, what if you got 2 positives? Away. Away, away, away. Now, what does that mean for the electric field in this area? Well, if there's no lines, it means that it's very weak. They're very far away. There is a weak field. But those positive charges are going to be pushed away. And in fact, here, as you get sort of farther away, it's actually going to get stronger because these lines are close together. The field's going to be actually stronger here than it is here. So it would actually start, positive test charge would start slow here and would sort of, and then speed up. And then of course as it gets farther and farther away again, it would not speed up as fast. But the main idea is away from positive, away from positive. Pretty easy, right? Like, are these easy guaranteed marks on the test? Yes. I really hope so. Positive, away, away. Okay, I got a negative plate, a metal plate that's negatively charged. Here's a positive single point charge, this is called. Away from positive. Is it done, that picture? What about over here? Is there an electric field over here? Absolutely. Towards negative. These take you a lot longer to draw than me to mark. It doesn't take long for me to mark this. I can make a decision in about a half a second.